Okay, just giving everyone a chance to come in, and I think they are in. Good afternoon, everybody. Thank you for joining us for this session here this afternoon. My name's John Chippendall, and I'm the CAS Community Outreach Manager in the northwest of England. So I'm speaking to you from a brightening to the west, Salford. And with me this afternoon, I have Ben Davis, who I will introduce shortly, and he's running this session on code reading in primary schools, which is part of the CAS Virtual Showcase program of events. 2 weeks of inspiring and engaging and informative talk, just like this one is going to be. So please do share your engagement this afternoon across Twitter or other social media. We're using the hashtag CAS Virtual 20. A couple of bits of housekeeping just before I hand over to Ben to start. And a few of you, if you've been into a few of these already, you will start to know these messages. First of all, you're all in listen-only mode. To communicate with us, ask any questions, please pop them into the questions box. I've had a bit of a chat with Ben, and we're happy to take questions as they come through, and/or we'll save a few to the end. So please do pop them in there. There are a number of handouts to go with Ben's talk this afternoon, and they are all available in the handout section of GoToWebinar. So wherever it's appearing on your screen, it's either in that direction or that direction. Open up the control panel, go to handouts, download those so that you've got them to hand as we go through this afternoon. So I won't talk for any longer. I'm going to hand over to Ben Davis, who is a primary school teacher, a real primary school teacher, as we can see, because we're going live to Ben in his school, which is St Paul's Primary in Withington. And I will let you introduce yourself a little bit more, Ben, and make a start on the presentation this afternoon. Thank you very much.
Oh, thank you, and good afternoon, everybody. So, yeah, thank you, John. That's a lovely introduction, and for now making me feel more nervous with your rather cool and composed. Yes, John, who is acting as Batman to my Robin, I think, or possibly Laurel to my Hardy. We shall
I think that might be a bit more accurate. Well, we'll find out, won't we? We'll find
wait
out.
till the end. We'll let people to. Yes. So, hello. I'm Ben Davis. As John says, I'm a primary school teacher. My class, or my bubble, to use the correct language, are currently doing some transition work on going to high school. So I've popped out to do this, as well as being a year 6 teacher. I'm also an SLE for computing and ICT, an NCC facilitator, a Barefoot ambassador, a CAS community leader, not using the H word and getting that right. Yes, but as John said, I'm currently in a physiotherapy room in school. The session that we're looking at today is code reading in primary schools, and hopefully, if I can get to move on. Yep. So what we're going to look at in this session is, well, I'll read these bits out to you, and then the rest of the presentation will form a backbone really for me to talk around. So it's to know what code reading can look like in primary computing, to identify ways that code reading can support learners' understanding, and the bulk of it really is to develop a range of strategies to use code reading activities. So hopefully, by sharing some resources that I've used myself or that I've developed for others to use in other roles, some might be ones that you can lift and use straight away, others might give you ideas on how you might use such activities. Okay. To start off, I'd like to spend a little time just sort of setting the scene and going through talking about what code reading is from my point of view, why you might want to use it and where you would use it. So really, they are activities where you are providing learners with codes or snippets of code and giving them focused questions about the code for them to answer. I find it a good way of giving children an opportunity to apply their understanding of the key computer science concept that you might be looking at in a particular unit. So be it repetition, selection, looking at variables. In terms of their formats, well, they can be done in a variety of ways. They can be the basis for class discussion or a small group discussion. They can be tailored to be independent activities that you complete on screen, with paper, or actually on paper. So there's a variety. What code reading isn't, and I'm sort of slightly burned from a previous time that I did this, and somebody just said, isn't it just about, don't they just read the words out or read the symbols out on the block? So I think I'll set my stall out and say, I don't think it's that, because we're not just getting them to bark out the instructions or say that it's a left arrow or a forward arrow or move 10 steps. We're actually thinking about how the blocks, how the command lines fit together to make a program, and the effect that each one has on the output of the program and how they work together. Why would you want to use code reading? Well, I've probably been using these sort of activities over 4 years. I'm probably using them now with increasing frequency in my computing lessons, and I've made some mistakes, and some of the pitfalls I'll mention later on when it's pertinent to do so. But these are some of the benefits that I think that my pupils are getting out, and myself are getting out of using them. So first, I think the opportunities for assessment for learning are really, really good. I'm getting lots of opportunities through these sorts of activities to sort of work out where my learners are, what things I need to do, what tweaks I need to make just to help them understand. I'm not as reliant on the end of unit programming task for my assessment. I still use it, and I'm not by no means am I sort of devaluing that at all. But these are little things that you can do on the way, so I can, I suppose, maximize the chance that my learners have got of being able to reach their full potential when they do that. And another benefit for me is, I think they're looking at the construct for the concept that you're looking at quite a lot of times. So they're looking at how those blocks fit together, whether to be to give you in Scratch, so you can put selection in, or if you're using repetition. One, they're using it, but they're regularly seeing it, and I think that's something that they can draw back on when they come to programming. For those of you that are in a subject leader capacity, I think they offer something that's a bit more tangible when it comes to giving evidence of progression or pupils' understanding of things. Sometimes you do have that element if you're using an end of unit program that the children have written, of how much of it is independent, how much of it was through paired programming. Was it equal representation, 50-50? These things offer you an additional, again, I'm not criticizing the other one, but they offer you additional, something more tangible. And recently I found that we've been using design a lot more in the last 2 years when designing and planning our programs. And I found that sort of tailoring some of these activities to the design process can develop their independence with using design. And also you can use them in a way that supports children's debugging by asking them to debug on some of the code activities. It can really hone their skills. And the final thing I think it's worth having a look at before we crack into some of these activities is thinking about where in the unit of work that you would place these. So these sorts of activities could, if they're put in the wrong position in a unit of work, have a high cognitive load. So I think it's really imperative that they come in a position after the learners have developed conceptual understanding of whatever the focus of the unit is, and after they've experienced the programming environment that they're going to be using. So they're not trying to learn about the command blocks when they're doing the code reading activity. They're not trying to learn about sequence whilst they're doing the code reading activity. They've had experience. They're focusing on analysing the program and pulling those bits out For those of you that might be using the use, modify, create approach, I think these sorts of activities align themselves with the sorts of things that you would be doing in modify phase of that. And certainly if you're using design, then you're going to be putting these activities in before children start designing and coming up with their algorithms for their final program. Right, so start. I'm just going to move my screen around a little bit and give myself a bit more of a view. There we go. So what I propose to do for the session is just to move through and talk about several activities and ways of doing this, ways that, as I mentioned earlier, ways that I've done or ways that I've sort of developed for other people in supporting them in their roles in school, and just talk about how these can be used. The idea is to start at year 1, go all the way up to year 6, and just go through the main bits, align them against the curriculum, so starting with sequencing, ending up with variables, and trying to get as many of the bits in between. Some of the activities are designed to be a bit more interactive, so we'll ask for your input in some way, shape or form and see if that works. So I'll start off with sequencing event that you might use in year 1. Now,
sorry to interrupt, Ben. Just before you jump into that, are you going to be sharing? Is it okay for me to share your slide deck as well as the handouts?
Yes, of course. Yeah.
Yeah. Apologies, everyone. That's my mistake. I've put the handouts as available to download, but we also want to put the slide deck. So yeah, we will send that to everyone. In fact, I might work on that now and put a link in the chat.
Okay.
Sorry to interrupt, Ben. It's just people are asking that they want to get hold of your slides as well. Right, I'll let you carry on.
I'll see that as a positive. There we are.
Yeah, definitely.
Right. So yes, I was going to say that people have questioned whether or not you would use these in Key Stage 1. I'm of the mindset that in maths, we don't leave using and applying to the most able, or we don't leave it till the later years. We give all children a chance to use and apply their understanding. I aim for the same thing with computing. I think it's our responsibility to modify the activities so they're appropriate to the learner. I've tried to pitch most of these sort of middle for that year group, and then talk about ways that we might offer extra support or offer more challenge to those children that need it. So this is an activity. Well, it's from a app called Meet the Foos. It's available iPad and on Android, and there's a web-based version. You can get free access to it if you go to the Hour of Code website, and there's a paid access as well, but you can get some free stuff through there. We use the free version, and we've not by any means exhausted it. And the basic premise is you've got this food chap here, the characters change as the game goes on, and you have to program them to get the donuts. And in that sort of gamification way, it becomes more challenging as you move along. So one of the activities when the children have their understanding that they have to put the blocks in a sequence, and if they don't put them in the correct sequence, then it won't actually go the right way that they want it, and they've had experience of that as well. So one activity that you might do with them is give them a screenshot of the program, and then give them a screenshot of the interface and a screenshot of 3 different programs. Have them printed out for them and ask them which program would actually complete the job. To support, I would have things like sort of little minifigures so the children can actually move and count out the steps as they're going, so they can work out each one. You might, to simplify it, you might just give one set of instruction and you're asking them the question, will this get the food to the goal? To add more challenge, you might have 3 screens that you've put in there and you're asking them to pair them up. I do think a really important question when we're doing any of these sorts of code reading activities is why. And it's that justification that the children can give you that really shows their understanding. So if they're going through and saying it's this one because first the foo will move right, then it'll need to jump, then it'll move right again and jump again, that's what you're after. But also if they're saying to you, well, it's not this one because the instruction tells it first to move right, but then to move left, which means it's going away. And although the other instructions get it back towards it, it won't get back far enough. So I think those things, those conversations are very valuable. And they're the things that, for me, these code reading activities, that's where I'm making my assessment for learning, right? If we move on now to a year 2 activity.
Just before you do, Ben, a couple of questions on that one, if that's okay.
Yeah.
Was that, Matthew's asking, was that meet the foo? How is foo spelled?
F-O-O-S, as in the Foo Fighters, but...
okay, meet the foo was Matthew.
F-O-O-S.
And yeah, also Rachel and Angela were asking the same question, just saying they missed what the tool was called. So it's Meet the Foos.
Yeah, there's a paid version of it, but you can access a free version through Hour of Code.
Super. Okay, cool. And just to let everyone know, whilst you were doing that, I've uploaded your presentation as a PDF file to WeTransfer. I'm popping the link in now so everyone can grab that and download it.
Okay, thank you very much.
Right, I'll let you carry on.
Oh no, I quite like this. Being interrupted. It's good.
Yeah.
Gives me a break. Right. If we move on to what some ideas that we could use with year 2 learners. So again, we're looking at sequence, but now we're looking at children who are making more independent choices when we're giving them code reading. And in terms of curriculum content, certainly I would be expecting them to make more decisions about the program that they're constructing, and certainly looking at ways to find out whether one program is more effective than another. So for this activity, as probably told, we're going to use Bbot. And this, for any of you that have done the NCCE primary programming algorithm course, this activity basically builds on or rips off, whichever way you want to use, the Bbot map activity that's on there. So we have a area like this, and on the course, delegates told you design a map that's 15 by 15 squares and place some places of interest for the Bbot to visit. So assuming that the children had done that, then you might want to do an activity like this. Now, for this activity, we can use, to go alongside it, a bit of interaction, handout 1, which is a sequence PDF. And on there are a couple of questions. So this is as you would use it with a class. So if you want to open the handout and use the question asking tool to actually answer the questions, and then John will keep me informed on how that's going. The first 3 programs ask you to locate. So we're always going to be starting at the Bbot from that home square and in the direction that it's facing. If you followed program 1, where would you end up? Program 2 and program 3. So if you want to put P3 and then selecting A, B, C, D, or E from the top of the sheet to say where you've ended up. For program 4, you should end up at a location, but also for that, I would be expecting learners to then I'd be asking them, can you give me a more effective route? So using fewest commands to get to that location. And if we can do that in the questions as well, if you use something like FD for forward, RT, LT, right turn, left turn, and BK if you wish to go backwards, being fancy about it. So I shall let you have a play with that one.
Yeah, so everyone can access the handouts there, and we've had, I think the fastest response was Nick Hughes, who had.
Nick.
Whoa, actually no, they're all flying through now. So I'll give it another second or so. Nick says hi as well. Hi, Nick. and then I will share some of the responses with you, Ben, and we can see how people have done.
So I'm already thinking of getting sidetracked with Nick in a conversation about the Mandalorian, but I shall leave that for another occasion.
The what? Sorry.
The Mandalorian. He'll understand.
Oh, okay, okay. Yeah, I'm sure that a reference will come. Yeah, yes! Exclamation mark pops up in the chat. Right. Okay. Anyway, back to Bebots. So we think a few people have said. So the first one we think is going to arrive at the tree.
Yep.
Which is tree. Number 2, the beach. E.
Yep.
Yeah, all good so far. Jennifer Lewis says then it will go to D for number 3, so the mountain.
Yeah.
Okay, excellent. Well done, Jennifer. Pleased to say that you are year Key Stage 1 attaining standard. And then was there a fourth one? Yeah, going to B. A few people have said the slide.
The slide should be, yeah. That part of my screen's covered, so but that's what I've got written down on my notes, but I can't actually cross-reference it.
Jennifer,
did anybody come up with a more sort of a shorter route using fewer commands to get to the slide?
We don't have that yet. If anybody can have a go at doing a shorter route to get to the slide, or what they think is one of the shortest routes, please pop it into the question menu in Bbot notation or whatever notation you want to use.
I just go for F for forward, left and right, and
yeah.
B for back. Yeah.
It's come in from Nick. Forward, right turn, forward, forward. Jonathan also said forward. Oh, they're all flying through now. Yeah, and you are all correct from what I can see.
Yeah.
Yeah, all very good. Most people are saying either forward, right, forward, forward, or right, forward, forward, left, forward.
Yep. Oh, thank you very much. So it's success on the first task, eh?
Hey,
I think more the fact that it worked, not that people were able to do it, but I'm not insulting there. It does sound like I am. I was just, the fact that we've actually got it to work is what I'm happy with. So, yeah. Right. So hopefully that would, so with that as a starting point, we could take that further. Again, if children need the extra support, again, you could be using the cutout Bbot figures that you can download from TTS or TES, using little counters to move around. Actually cutting the arrows out and putting them on the map will also help. Other activities that you can do that couldn't share as well, but you might give children 2 cards that are using this exactly the same symbols but in different sequence, and ask them to explain why one gets you to a certain location and why the other one doesn't. So the onus on them is not on them creating the program, but explaining how the program works or why the program doesn't work. Right. So that's checking. Goodness. Right. We'll move on to Key Stage 2 activities. Now, before actually showing you any, I'm just going to draw attention to this website, which I use quite a bit, but I've used to produce a lot of the scratch blocks that are on this. The link to it was in the presentation in the speaker's notes, but it's called Scratch Blocks, and basically you go onto there, you use the help section, it tells you how to do it, but you can create your own scratch blocks for download as an image file, which for those of you that have used the zoom function and then screenshot them and then try to create transparent backgrounds, this is a godsend. You can really blow them up quite large. They're really useful for displays as well. But be prepared, if you go off and use them, you can write off a couple of hours, because you will sort of play about with it, and you get almost, when you work out how to do all the things like the drop down menus, you get those little fist pump moments that you get when you first get an LED to come on when you're doing physical computing. So that's there, and that's what I've used for most of the blocks that reference Scratch. So if we look at an activity that could use in lower key stage 2, so this is looking at repetition, and the activity that the children had to do and they were looking at in the unit was creating just simple animations. So over here you've got code that the children have been provided with, and here just a simple storyboard. And what I'm wanting them to do is to actually represent the animation. Now, not been able to access children's work in the way that I have been able to, or usually would be able to. I've just mocked one up here. So these are the things that are going to happen on the animation. So instead of representing the block of repeat 2, I'm actually expecting them to see that they think that that is going to happen twice. So they got sprite moves 10 steps, sprite changes color, and then they've got that again. When I've done this, I've asked them to highlight or to annotate in a certain way the ones that were inside the repeat, just as an additional sort of measure for marking. And then they've got the sprite gets bigger one here, and that's outside the loop. Okay. After using that, then we have been able to, and this is one that I've got one of the key worker children to do a couple of weeks ago. I was doing a session like this, but they can then use the same design to actually plan their animation. So they've got how they're going to start the animation. They've mentioned it's going to say howdy partner. Then they've got these 3 steps to the animation that are going to be in the loop. So they put ticks there to show that they're in the repeat. And then at the end, see you later, alligator. So with authentic spelling as well, I should say. So that the idea of using something like this in terms of a design to almost in a way that you would in English to strip a piece of writing into its constituent parts. Here we're looking at the different steps in an animation, and then we're moving it on here to using it to plan our animation. Now, in between that, I would do an activity, something like this, probably not to this degree of difficulty, but I've put this on here as a way that do it with you on one built-in break for my voice so I could have a drink. But if you were to get the handout 2, which goes alongside this one, what I'd probably do with children is the whole idea is them realizing how many steps in this animation and the effect of using the repeat, the count control loop has on the program as a whole. And I might be asking them, can you show me a program that there will be 9 steps of animation, and can you show me a program that's got more than 4 steps? And I'm asking for their justifications. A way that I thought we could do it, so it works this way, is we've got 4 boxes here. So box 1, in the animation, it would change color the same number of times that it took 10 steps. In box 2, any programs where it changes size more times than it takes steps. In box 3, any programs where it takes 10 steps more times than it changes color. And the final one, any time it changes color more times than it changes size. So for this one, if you would like to pick a box and then go through the handout and just identify any of the programs that you think go in that box. So again, we'll do that in questions. So if you're doing box 2, for example, box 2, and then just put the letters of the program from handout 2 repetition that meet that criteria. So you're looking at the number of steps and whether it would carry out one of the blocks more times than the other block or the same number of times as that block. Okay, I shall let you play with that one.
Well, thank you, Ben. If anybody's got any issues in accessing the handouts, give me a shout, but I think we were fine in getting to those last time. I've just double checked them here. They do appear to be working. I love that scratch block image generator, Ben. I'm going to be using that.
Right, yeah, so I've got a pitfall to mention. Oh, I failed to mention a pitfall earlier. I'll do them all at the end. Would you remind me if I'm not?
Yeah,
of course. My pitfalls are. There is one built in at the end as a way of should remind myself. But.
Okay. And I will just monitor this on. Not as speedy as the previous task, but I think this. Oh, we've got Nick. He's back. So here we go. Thank you, Nick. Box 1, we have programs A, C, E, F, and I.
Yep. I think I missed one there, but
House point to Nick. Maybe you've missed one. Just go back over your work, Nick, and just check. Identify.
Double check. Sure.
He says, I will. We've got Jonathan. So box 2, program B, program D, and program G.
Yes, excellent, Jonathan. Yep, they're same as I've got on my list.
Well done to you. Would all of them fit into box 4, says Matthew?
Change colour. I don't have that. Change. Now this is the thing. I'm now doubting myself.
I do that all the time.
Yeah. If you look at program A, for example, so in the animation, first it would move 10 steps, then it would change colour, then it would move 10 steps again, and then it would change colour a second time, but it would only change size once. So in terms of the animation, although this is the thing that we're trying to get through with children with this sort of activity, is the block itself is only used once, but the action of the block is carried out twice because of the use of the repetition. So for box A, it would go into box, but the other ones, let's have a look at the program B. It repeats the change it changes the size 3 times, and it moves 10 steps on one occasion. Things that you would put into the program, like when children would be writing program B, I'd expect them to put a 10-second, a 1-second pause in, so you can actually see that animation. And if you go back, when you're looking at them, you'll see on the, I don't know if I can do that. Yeah, here on this, they've got 1 second, 1 second, because they want them to actually pause. When I'm using the programs, I don't tend to put those things that we add in just really just to keep the programs as small as possible and keep them to a minimum size and be able to get things onto the screen. But any more, John, or should we move on?
We do have more, but I'm just conscious of time for you as well. So thank you to everybody who contributed. But I think would you like to move on to your next example?
Yes, yep. So if we move on, so I'm going to have just a brief look at selection, and there's a handout to go along with this, but we're not actually going to do the handout, so it's there if you want the reference later. But I've used this activity when introducing selection to children, and we've been in a position where we have already done some work on conditions in programs and the effect of having a condition that's true, how it acts on the program. So we're looking at programs that start when the condition is true, or actions that are carried out, and actions. So in the second one, that are carried out until the condition is true. Those of you that have taught selection, this is one way of sort of really getting a hold of the thing where children can often forget to put the forever loop into. We've got feedback there. Are you saying something, John? No, all right, carry on. I've lost my thread, so I shall try and get it back. Where children quite often forget about the need to put in that forever loop so that the condition is repeatedly checked to see if it's true or false, and make the carry out the actions. So in this sort of activity, what I'd be doing, and if you look at the sheet, it's set up for this way. This is more of how I would use it with children. Is first they're going through and they're identifying the condition in each program. So this is something that they've got experience of. They've looked at the shape of condition blocks. They've used these sorts of ones. We've talked about how it is a condition. And then I'm asking them to identify what they think will happen when the condition is true. So in this one, something's going to be carried out. In this one, an action that was being carried out is going to be stopped. For these two, the latter two, they would probably be identifying the action in the if, after the if statement is going to be carried out. And then I'll ask them to write the programs, or depending on time, provide them with the programs to run the programs to make the condition true and see what happens. And it's then we get into a conversation around these two about, well, what is different between the two of them, identifying that they've got the same structure, they're both using selection, using the if-then structure, but this one has forever, this one doesn't, and what is the effect of one of them having forever and one of them not having forever. So in some ways I'm taking something that's a common error, a misconception, and I'm trying to preempt that and give pupils an understanding of why they need to do it by getting them to experience it not working, we say. Another activity that we can do, so this is using physical computing. Again, you've got the handout for this, but not for us to use now. This is using Crumble, and children prior to doing this would have done some work where they've identified light sequences and they've created their own light sequences, and start an activity off by running a video like this, which shows a light sequence, hopefully. Yes, hopefully it's showing at your end too. And then I'm asking them to identify the program which will give that output, and giving them a selection of programs. So similar to some of the other activities that we've seen so far. And again, what I'm asking them to do is go through each one and tell me, will that program give you the output that you've just seen? I would have the output up on the board. They have the sheet, so the output can be, the video can be run several times so they can keep cross-referencing it. But what I found with this is, yes, they find the right one, they can explain why, but also it's really valuable them being able to tell you why a certain program won't give you that output. And that thing of them honing in on the command line that means it can't be that because it says this, I think has supported their debugging work. Because I find over time they're becoming better at looking at the output, looking where something goes wrong, and then sort of going, right, I need to go to that bit of the program, rather than just starting at the top and checking each line, saying, yeah, that works, that works, that works, that works. They know that bit works. They know where it went wrong, so they know where to start looking. Okay, and then moving on to our final activity we've got here. To put some animation there, didn't mean to. We have got activities that you could do with variables. So, I think minefield variables, because when you start adding them in, there can be so much complexity that goes alongside them, and things like, what do you set them to? Do you change their names? What do you call them? So there are a few activities here that might help children get a better understanding of all the things that you have to do when you start using variables in programs. So you might start off activity like this, where you've got two programs up and you're identifying that actually these two programs will have similar output when they run. They'll both set a number to 30 and they will both act as a countdown timer. And you might want to then ask children, right, have a sorting table, T-table, and you've got similarities and differences, and you're asking them to identify what's the same. So they both have a variable called time. They both set it to this, so they both initialize it to 30, and they both decrease by a value of 1. And then you're looking at things that are different between the two programs. So one of them uses a condition, and one of them uses a count, control, loop. And when I've used this program, we've done this sort of activity, and then I think it's quite nice, is I've said to the children, right, well, which one do you think is the best? And they give different reasons, but then put in the, well, actually, if I wanted to change the number that the timer starts on, what else needs to be changed in the program? And then they go off and they think about that, and realizing that if you use this one, for example, then changing the number, it'll just keep repeating until it's 0, whereas if you change the initial value here, you have to change the repeats, so the number of times that it counts through the loop, so it coincides. So just different ways of getting them to explore. And so the final activity that we will do, which you do need handout 5 for, but you can do if you're on screen, you can just leave it on screen. But you're looking at this one being program A, this one being program B, and this one being program C. And this takes so the idea, some of the activities you might have seen with the White Rose Maths resources, but we're looking at shapes, and you're looking at, does this property effect relate to all of the shapes, some of the shapes, one of the shapes, or none of the shapes? We'll do a similar thing with programs that are using variables. And again, if you want to pop your answers in the box, but we'll just sort of rattle through them. I'll give it 5 seconds for each, and then at the end of doing all, I'll do a few of them, and then I'll ask John just to sort of see how people did with this one. So the first one that we might want is, so which of these programs contain a variable? So program A, program B, program C, all of them, some of them. So you might, and then we might look at, do any of the programs contain a variable that can change value? So again, the pupils are identifying, as I said before, with cognitive load, this is after they've got a good understanding of variables, they've had some experience in the use modify cycle of programming them with them. So these are not things that they don't know. We're asking them to analyze the programs to look for these things.
So a few responses coming through there, Ben. Sorry, I was just responding to something. So Katie says C, question mark. Nick says all. Jonathan says, oh, I'm not supposed to be saying names. That's what I was just receiving a message about. Right, so all, or C, or A and B. We've got a real mixture that are coming through here, Ben.
Well, I thought I'd just do, because of time, if I just went through and then just gave an example, then I might just, or do people want me to? So for that one, they all contain a variable, and for this one, sorry, a variable that can change. So a program A contains it because the variable can change if the green circle is touched, and in this one, the lives can change if the red circle is touched. And if we just do, I'll pick 2 more. Contains a variable that has its initial value set to 0. So we get children thinking about, not only are they using the variable, but they need to remember that they're responsible for giving it its initial value. Do we have anyone's on that?
A?
Yep, A for that one. And I'll just go through, there are a few more examples. I won't take, I'd rather have opportunity to take questions, but this one is one that I like as well. It contains a variable that has not been renamed, so no, it's bordered on double negative, but it, in a way of making sure that children are not using variable 1, variable 2, variable 3, but it's again expressing to them the importance of giving that variable a context, giving it a name, so that they understand that name can be used in the program, and they don't think, oh, was lives variable 3 or was timer variable 3, if that makes sense. So yep. Move on. So yeah, to go over, hopefully you find some of those activities of use and start thinking about ways that you may be able to use these sorts of activities to support your teaching and learning, and seeing that the value in an additional assessment, and thinking about certainly the way that it promotes higher order skills, that you've got justifying, rationalizing, comparing in there. So questions if you have one, but I shall go through this. This helps me remember one of my pitfalls. When I first discovered this code, Scratch blocks, I thought, oh, particularly with that animation unit, I'll make some blocks up and put them into the programs for the children when they were representing the animations in a storyboard. So I made jump, because I thought jump would be a nice one to have. And then when you come to write the program, the children want to use jump, which isn't there. So there's that as a pitfall. Other things, Let's go back to the Bebop activity. I first used the Bebop app and did some screenshots of that and tried to use that after the map activity. And I think the difference moving from one context to another was a bit of a problem, which is why I thought, well, I'll base it on the NCC idea of the Bebop map. I think trying to keep the cognitive load as low as possible, so we're not expecting additional things off the children. And then the other thing is doing these sorts of worksheets and just overloading them with nice images and screenshots, and then realizing actually there isn't that much for the children to do on them. So making sure that they are analysing, that they are justifying, that it's about them thinking about the programme and not just reading the words that are on the block. So if there are any questions, John?
That's fantastic. So thank you so much, Ben. I think all of the questions that have come in, we've responded to and answered as we've gone along. Just as I'm wrapping up now, if anybody does have any final questions, pop them in the question box. But I'm conscious that we've taken our full amount of time, but so worth it. And the feedback is coming through in volumes, saying the same thing in the question box. No further questions, but thanks so much. Really great session, fantastic, from people who I will not name. I made a bit of a joke at the beginning there, Ben, saying, you know, we come to you, we're a teacher live in the classroom, but it's so evident when you speak with yourself who is based in school that you are providing activities that people can just take away and use and are of real value in the classroom straight away. And that's super. I've been scribbling away. I'm going to be pinching some of these ideas myself, Ben. So thank you very much. Just while I'm wrapping up, do you want to just go back to your first slide so people can see your contact details if they do have any further questions? They can.
I should have it as a last. I should have it as a last slide as well.
There we go. Brilliant. Yeah, thank you. Just in case if anyone does want to get in contact further. So I'm going to wrap things up, and I'm going to say thank you very much for joining this session, which is part of the CAS Virtual Showcase 2020. There are going to be recordings of these sessions coming out in the near future. And as I finish the webinar now, an evaluation form will appear. Please do take a moment to fill that in. It's really valuable for us to receive evaluations from everyone. And I hope to see you in some more of the sessions coming up over the next couple of weeks. So thanks so much, Ben, again, and I will finish the recording. Speak to you soon.
All right.